island is on track so far. It also means the Crown Prince can keep a close eye on his pet project. August 2002, a year in, and the island team is ahead of schedule. 5 miles of the breakwater stands firm. 8 palm fronds break through the azure seas, but it's a grueling and difficult process. Rainbowing is a common operation in land reclamation, but this is no ordinary reclamation project. There's no mold for the palm shape and no fixed points to get bearings from. The unique shape makes it a nightmare to build because the whole design relies on accuracy. This enormous structure has 35 miles of waterfront, and almost all of it is curved. To make things more difficult, it's impossible to tell from the ground if the sand is falling in the right place. The only way to complete this task is to use state-of-the-art technology.
Prior to GPS, we couldn't have done this job. There are only 2 straight lines in this project. All the rest of them are curved.
It's all down to a team of 5 men who walk the perimeter of the island every day as it takes shape. Summer temperatures reach a searing 114 degrees Fahrenheit. Humidity hits 95%. With heavy packs strapped to their backs, these mobile receivers create a grid reference for the island. Receiving signals from space and a fixed position on land, the height and position of the sandbars is recorded. With these coordinates, dredgers can sail into the exact position and rainbow the sand with pinpoint accuracy. Only by using state-of-the-art GPS technology can this awesome megastructure take shape. As the world watches, Palm Jumeirah becomes a reality. At the same time, faith in this tiny emirate is restored. Dubai emerges as a safe haven in the Middle East. Beaches fill up again. Business resumes. The Crown Prince's gamble to continue construction has paid off. But there's still a deadline to meet. The island must be built by 2006. Coordination between the 2 teams, one building the breakwater and the other reclaiming the sand island, is crucial. If they don't work in perfect synchronicity, the whole project could be thrown into jeopardy.
If the breakwater progressed too quickly, it would cut off access for the reclamation contractor. If the reclamation went too quickly, then it would be at risk for the storms. We couldn't let one get ahead of the other in any way.
It's a delicate balance, but a year into the project, work is on schedule. Against all odds, the Palm Island rises above the waves, protected by the ever-increasing sea wall. It's a symbol of engineering achievement, but the engineer's biggest challenge is still to come. How to make the island safe to build on. The majestic Palm Island is made only from sand, but sand is unstable and highly susceptible to the movement of water around it. It also takes time to settle before it's strong enough to build on. But this awesome structure will have to support a city of 120,000 people, and their safety relies on firm foundations. There's no other option than to make this massive sand island rock solid. But how? Palm Jumeirah finally rises from the sea, yet engineers face another immense challenge: to turn a desolate island into a thriving city. October 2002. Dubai is building one of the world's boldest engineering projects in the Persian Gulf. A 3.5-mile island in the shape of a palm tree, made entirely of natural materials. A year into the build, 2/3 of the breakwater is complete. 5 miles of massive rocks piled 10 feet high above the waves and are backed by 220 yards of beach that will eventually carry 22 hotels. Behind this sea defense, the first 8 palm fronds made of sand rise above the water. Dredgers spray sand from the sea floor in a method called rainbowing to create the first half of the 3.5-mile island. But building a man-made structure in the middle of the sea with only rock and sand throws up challenges every step of the way. The team battles constantly with nature as the sea erodes their work.
We worried initially that we could actually do it, that we could place the sand where it should be, that we could place the rocks where they should be.
The teams race to finish the project, but then engineers discover a problem that could put the whole project in jeopardy. The decision to start construction before completing the research has finally caught up with them.
Coming in or going out.
The sea isn't circulating around this massive megastructure as they planned. Tides aren't flushing the system properly, and clean water isn't moving fast enough around the inner waterway. The water is in serious danger of becoming stagnant. People have paid millions for a piece of this paradise island. Green, fetid water isn't going to work. A solution must be found, and changes must be made to the design. But all the time, Palm Jumeirah is taking shape to the original plan. Further tests are run on the computer. A solution is found just in time, and it's simple. The seawall must have 2 breaks in it. 2 4-lane bridges link the sections of the breakwater. These 2 openings mean enough fresh-flowing water can get into the system. 2 months later, in October, the island reclamation is finished. 123 million cubic yards of sand have been pumped into the Persian Gulf to create the perfect palm shape. In just over 2 years, Palm Jumeirah has finally risen from the sea. The deadline has been met just in time, and phase 1 of this monumental engineering challenge has been accomplished. But there's still a very long way to go. Phase 1 is only the completion of the foundations. Now, to fulfill the Crown Prince's dream, 4,500 houses and apartments, hotels and shopping malls must be built along the waterfront. This sand island must support an entire city. But here lies the next major problem. The sand isn't strong enough to build on. Over time, the sand will compact naturally, but this would take years, and time is something engineers don't have. Construction of the infrastructure must start immediately. And if the schedule wasn't pressure enough, there's another more important reason why the foundations of this city must be made extra strong. Dubai sits just on the edge of a major earthquake zone. Bam, Iran, north of the Persian Gulf. 5:26 a.m., December 26, 2003. The town is hit by a quake measuring a massive 6.6 on the Richter scale. In minutes, 60% of the buildings are leveled. 43,000 are dead, 20,000 injured, and 60,000 are homeless. Following this, multiple quakes hit Dubai 300 miles across the Persian Gulf. It's a wake-up call to the Palm Island project. If the epicenter hit Dubai, it could spell disaster.
Should an earthquake come through the area, the sand might lose its cohesiveness down deep. The reclamation process piles sand one grain upon another. If we put the ocean around it, you see the island. However, the lateral forces of an earthquake can make the island disappear.
This terrifying phenomenon is called a liquefaction. It happens when a quake shakes the Earth's surface, causing sand particles to move. As the sand compacts, it pushes the water between the particles upwards, making the ground liquefy. The island would sink back into the sea. This was terrifyingly evident in Kobe, Japan. In 1995,